Imagine looking up at the night sky, billions of stars, countless galaxies, all humming with an energy that seems infinite. For almost 100 years, this was our scientific gospel. The universe was on a one-way trip, expanding forever, fueled by an endless cosmic engine. Stars would die, yes, but new ones would be born. The cosmic story would just keep writing itself, chapter after chapter, into eternity. This was the comfortable, predictable reality we built our understanding of everything upon. But what if that story has a final page? What if the ink is running out? In labs and observatories around the world, a new, unsettling idea is taking hold. It's a whisper at first, a faint signal in the cosmic noise, but it's growing louder. Scientists are looking at the data, rerunning the numbers, and the conclusion they're tentatively reaching is both profound and terrifying. The universe, our universe, might be running out of steam. This isn't just an academic debate. This is a potential rewrite of the fundamental laws of physics. It challenges the very nature of time, space, and existence itself. So, are we living in a dying cosmos? Is the brilliant light show of the universe slowly, almost imperceptibly, dimming before our eyes? Let's dive into the science that's shaking the foundations of cosmology. To understand why this is such a big deal, we need to rewind to the 1920s and meet two giants of astronomy, Edwin Hubble and Georges Lemaitre. Using the most powerful telescopes of their time, they made a groundbreaking discovery. They observed that distant galaxies weren't just sitting still. They were all moving away from us. And the farther away a galaxy was, the faster it seemed to be receding. This was the first concrete evidence for the expansion of the universe. It was a revolutionary idea that completely changed our cosmic perspective. It meant the universe wasn't static and eternal. It had a beginning, it had a history. This discovery gave birth to the Big Bang Theory, the idea that everything, all of space, time, and energy, burst forth from a single, incredibly hot and dense point, about 13.8 billion years ago. Since then, the story has been one of continuous expansion, like a cosmic balloon being inflated. For decades, the biggest question in cosmology was, what's the ultimate fate of this expansion? Will it go on forever, or will gravity eventually win, pulling everything back together in a big crunch? Think of it like throwing a ball into the air. If you throw it hard enough, it escapes Earth's gravity and never comes back down. If you don't, gravity pulls it back. For the universe, the escape velocity was determined by the total amount of matter and energy it contained. For a long time, the debate raged on. But then, in the late 1990s, came another shock. Two independent teams of astronomers studying distant supernovae exploding, stars that act as cosmic lighthouses, found something completely unexpected. The expansion of the universe wasn't slowing down as everyone thought. It was speeding up. It was accelerating. This was like throwing a ball into the air and watching it suddenly shoot upwards faster and faster on its own. It made no sense. To explain this bizarre phenomenon, physicists proposed the existence of a mysterious, invisible force pushing everything apart. They called it dark energy. This isn't just some fringe idea. It's now a cornerstone of our standard model of cosmology. We can't see it, we can't touch it, but we can measure its effect. And its effect is huge. Dark energy is thought to make up nearly 70% of the entire universe. It's the dominant component of the cosmos, a pervasive anti-gravity that's driving the runaway expansion. This discovery seemed to seal the universe's fate. If dark energy was a constant, unchanging property of space itself, then the expansion would continue accelerating forever. Galaxies would fly apart from each other so fast that eventually, the sky would become dark and empty. The universe would end not with a bang, but with a cold, lonely whimper known as the Big Freeze. That was the leading theory. Until now. So what's changed? The new clues come from our most detailed maps of the cosmos ever created. Projects like the Dark Energy Survey and data from the Planck satellite have meticulously charted the distribution of galaxies, and the faint afterglow of the Big Bang, the cosmic microwave background. They've given us an unprecedentedly clear snapshot of the universe, both in its infancy and as it is today. And when a team of scientists led by Professor Sabir Sarkar at the University of Oxford analyzed this vast trove of data, they found a discrepancy, a tension. The data seemed to hint that the power of dark energy might not be constant after all. Instead of being a steady, unchanging force, it might be weakening over time. Imagine that cosmic engine pushing everything apart is starting to sputter. The team's analysis suggested that the evidence for cosmic acceleration, while still present, might be less conclusive than we once thought. They introduced a new model where dark energy is dynamic, a property that can evolve and decay. According to their calculations, this evolving dark energy could be slowly fading away. If this is true, the implications are staggering. A universe with weakening dark energy behaves very differently from one with constant dark energy. The acceleration would slow down, stop, and then reverse. Gravity, the patient, ever-present force, would finally take over. If dark energy is indeed fading, our universe's ultimate destiny is not a big freeze, but a big crunch. The expansion would grind to a halt billions of years from now, and then begin the long, slow process of contraction. Galaxies would stop racing away from each other and start moving closer. Over eons, the universe would get smaller, hotter, and denser. Distant galaxies would reappear in our sky, their light blue shifted as they hurtled toward us. Eventually, everything would merge. Galaxies would collide, stars would be ripped apart, and the fabric of space-time itself would be squeezed back into the primordial singularity from which it all began. A cosmic reset button. It's a dramatic and almost poetic end, a perfect mirror image of the Big Bang. But this isn't the only possibility. Other theories propose that a decaying dark energy could lead to something even stranger. Some physicists speculate that this change could trigger a phase transition in the vacuum of space itself, similar to how water can turn into ice. This could fundamentally alter the laws of physics, creating a new bubble-like universe that expands and annihilates our own. It's a concept straight out of science fiction, but it's grounded in theoretical physics. What we are witnessing is science in action. A long-held consensus is being challenged by new evidence and fresh ideas. It's a reminder that our understanding of the universe is constantly evolving. Now, it's crucial to state that this is not a settled debate. The idea of decaying dark energy is still very much a hypothesis, and it's controversial. Many cosmologists stand by the Standard Model, pointing out that the statistical evidence for acceleration is still very strong, and that these new findings could be the result of subtle errors in data analysis or unaccounted for cosmic phenomena. It's like trying to detect a faint whisper in a hurricane. Our cosmic measurements are incredibly complex, and there are many potential sources of noise and uncertainty. For example, maybe our region of the universe is just a bit emptier than average, creating a local bubble that makes the expansion look different from here than it would from somewhere else. Scientists are now racing to gather more data to resolve this tension. Upcoming observatories like the Vera C. Rubin Observatory and the Euclid Space Telescope will map the universe with even greater precision. They will measure the positions and distances of billions of galaxies, giving us a much sharper view of how the cosmic expansion has changed over time. These next-generation surveys will be the ultimate arbiter in this debate. They will either confirm the Standard Model of constant dark energy, or they will provide the smoking gun evidence that our universe is indeed running out of gas. So, where does this leave us? We're standing at a fascinating crossroads in our quest to understand the cosmos. For the first time in a generation, the ultimate fate of the universe is genuinely up for grabs. Will it be an eternal, lonely expansion into the cold darkness of the Big Freeze? Or will it be a fiery, dramatic collapse in a big crunch, perhaps setting the stage for a new universe to be born from the ashes? Or could it be something else entirely, something we haven't even imagined yet? The fact that we can even ask these questions and seek answers in the light from distant stars is a testament to human curiosity. We are a tiny part of this vast cosmic drama, but we are also its observers, its storytellers. Whatever the final answer may be, the journey to find it will undoubtedly reveal deeper truths about the nature of reality. The universe, it seems, is far from done revealing its secrets. It's more mysterious, more complex, and more interesting than we ever thought. And the next chapter in its story is just beginning to be written. Thank you so much for joining me on this cosmic journey today. It's a mind-bending topic, and I'm curious to hear your thoughts. Do you think the universe will end in a freeze or a crunch? Let me know in the comments below. If you enjoyed this exploration of the cosmos, please hit that like button and subscribe for more deep dives into science and the universe. It really helps the channel grow. Thanks again for watching, and as always, keep looking up.